Let's use transformation to sketch y equals -2 parenthesis x plus 3 squared plus 4. It's already written in standard form, but this is another way. Using transformations is another way than we've seen before for graphing these quadratic second-degree functions. Let's follow the steps that we discussed in the outline. Step 1, we're going to look at our basic graph for this function. The most basic graph would be y equals x squared. And we need to remember that that's just a happy face parabola with a vertex at the origin 0, 0. Step 2 and step 3, we're going to look at our graph and see our equation, how many moves to the right or left or how many moves up or down we're going to make. Well, first of all, we have -2 parenthesis x plus 3 parenthesis squared. So within the actual evaluation of the function, we took out the x in y equals x squared. We replaced it with x plus 3. So when you add a number to the evaluation of the function, in other words, we add the number 3 to the x, that means we're going to be shifting it left. Shift our basic function graph left 3 units. Now look at the number added at the end. When we add a number at the end of the function y equals x squared, that means we're going to shift up. If it were subtraction, we would shift down. So here we're going to shift up 4 units. And then recognize from the standard form, that tells us that our hk, the vertex of this parabola, is located at the ordered pair hk equals -3, 4. Now step 4, we're going to find a few points, and we do that by letting x equal some value and processing that through the function to find its y partner. Let's let x equal 0. Y equals -2 parenthesis 0 plus 3 squared plus 4. Just simplify that. Y equals -2 times 9 plus 3. Y equals -18 plus 4. Y equals -14. That gives us an ordered pair. 0 for the x partner, -4 for the y partner. Let's let x equal -3 this time and process it to find the y partner. Y equals -2 parenthesis -3 plus 3 squared plus 4 is -2 times 0 squared plus 4. Y equals 4. So we have 2 ordered pairs here. The x coordinate is 0. We found the y partner -14. And when the x was -3, we found the y partner 4. Okay, for step 5, we're going to identify the vertex, the axis, the domain, the range, and make the graph. Okay, so we'll make some marks on our x and y axis. The vertex v we found up in the end of step 3. Let's see, it is the ordered pair hk equals -3, 4. So let's put that vertex right there at -3, +4. And then we have the graph going through -14 on the y-axis. So there's our vertex, -3, 4. We're listing them now. Here's the axis of symmetry. It's the line x equals h, which is -3. It's an equation of a line, x equals -3. And then our domain, well, look at that graph. For every x value, you'll find a point somewhere. So the domain is all x values from -infinity to +infinity. And the range has no low value, so it's coming up from -infinity, but the highest value it reaches is +4. And it includes +4 for a y value. So the range is equal to open parenthesis -infinity to +4, boxy bracket to include the 4. There's our graph, and there's our list of the vertex, the axis, the domain, and the range.